Good afternoon, everyone, and welcome to Construction Canada's webinar on the new generation of spray foam by BASF Canada. My name is Nitya, and I'll be moderating today's presentation. Before I introduce the speakers, please note your mics are muted. That said, if you have any questions for our speakers, feel free to post them in the Q&A forum. We will address as many questions as possible at the end of the presentation. If you have any connectivity or Zoom-related questions, you can use the chat feature to communicate with us, and we'll do our best to help you. Today's presentation is being recorded. It will be available on Construction Canada website, so you can access it whenever you need to. Now, I'd like to introduce our speakers. Chris Jansen is Field Applications and Warranties Manager at BASF. Ibrahim Hussain is Construction and Standards Regulations Specialist at BASF. Michael Pace is the owner of Building Resources, Inc. In today's presentation, the speakers will highlight upcoming code changes and the new generation of spray foam using HFO blowing agents. Now, before I turn things over to Chris, we have a poll question that we would like you to answer. It's going to come up on your screen right now. It's a simple question. What best defines your job role? Are you an architect or engineer or a specifier, a spray contractor or other? We'd just like to get a sense of who's here today. And we will be sharing the results in a moment. Okay, so we have a good mix here, and most of them seem to be architects. Now I hand things over to Chris. Chris, you can take over.
Good afternoon, everybody. I guess some good morning for those of you out in the BC area. Thank you everyone for joining us. Looks like we have almost 200 attendees so far that have dialed in, so great turnout, very excited about that. Just kind of a brief introduction into the seminar before we start getting into the overall topics. What we really want to talk to you guys today about some of the regulatory changes, both on a compliance standpoint from Environment and Climate Change Canada, and also the National Building Code and Standards requirements. So you'll be learning a little bit about hydrofluoroolefin blowing agents in our new WALLTITE CM01 product, along with environmental product declarations, some of the code changes that are coinciding with the change out of the chemistry, and then some of the applications and benefits and how to kind of address your specifications to make sure you're ready for the code changes. So a brief history on spray foam overall, or where it can be used. You know, spray foam's been around for well over 40 years now. It can be used in all sorts of applications, interior and exterior applications, below grade, above grade, and in your industrial buildings, commercial, institutional, like schools and hospitals, residential and multi-unit residential buildings as well too. Overall, what is spray foam? Again, we're not going to get into too much chemistry on here. But basically, spray foam, for those of you who don't know, it's a manufactured on site. The spray foam applicators, they come on site with either a 5-ton truck or a pull-behind trailer. We would have a drum of isocyanate and a drum of resin. It goes through a proportioner unit that automatically meters it to a fixed ratio and sends it 300 feet through 2 sets of hoses that gets mixed in a spray foam application gun. About 2 feet away from the substrate, and it starts reacting in the air as it's traveling from the gun at about 1,000 psi into the wall, and starts rising up within about 5 seconds, and is sets and solid within about a minute to the touch. So again, there's an isocyanate on the resin side of things. Everything's kind of still the same there with regards to we're using polyols, flame retardants, catalysts, and surfactants. Very similar chemistry to what we've been using over these past 40 years. The main thing that's changing though right now is we're going through another blowing agent change for regulatory requirements on that. And that's taking into effect at the end of this year. So again, you know, a little bit of history before I turn it over to Ibrahim is we started in 1960. Polyurethanes have been around for years. Before that, we're probably all sitting on polyurethane right now in our office chairs or in our cars. So yeah, spray foam's been used since the 1960s. We launched it in Canada with our WALLTITE product line in the 1980s. Then we went through some blowing agent changeovers with the Montreal Protocol starting in 1990 with CFC phase out, and again in 2010 with HCFC phase out. And now we're going into 2021 with our HFC phase out. And at that point, I'll turn it over to Ibrahim, and he can start getting into a little bit of the regulatory and the code requirements that are changing.
All right, thank you, Chris. So the main reason why we had to go through all those changes throughout the years with the blowing agents is their ozone depleting potential. So we'll start by defining what an ODP is, or ozone depleting potential. It's basically a measure of how destructive a certain substance is to the ozone layer comparing to CFC11. So back in the 90s when CFCs were being used, actually the Montreal Protocol was, which is a global environmental agreement that was there to regulate and control the production and use of ozone depleting substances. So that was signed in 1989, and then around 1996, that's when we phased out from CFCs, and those were replaced with HCFCs. You can see here from this chart that the ODP of HCFCs were much lower than CFC. However, they still had, they were still harmful to the ozone layer. So in 2010, those were phased out, replaced with HFC, which is what we're using until now, and what we'll be using until the end of this year. But the spray foam industry as a whole, by 2010, we completely got rid of any ODP blowing agent. So you might be wondering, why are we phasing out from HFCs if they have no ODP? And the reason behind that is their global warming potential. Again, let's define this term. It's basically how much heat a greenhouse gas traps in the atmosphere relative to CO2. So because these blowing agents and HFC have a high GWP, they're now being phased out thanks to the Kigali Amendment to the Montreal Protocol. So basically that amendment was there to deal with greenhouse gases and address climate change. So it was targeting HFCs in particular. And in Canada, we implemented that regulation on January 1st, 2019, so not too long ago. And now all HFCs will be replaced with HFO, which has a GWP of less than 1. So if you look at the history from CFC until now, that's a really long way, and we've improved a lot. What that means is by January 1st, 2021, blowing agents, HFC blowing agents can no longer be used in any foam plastic. So that would include XPS as well. It's not specifically for spray foam. In terms of spray foam, any resin component will automatically expire on December 31st, 2020. So even if it had an actual expiry date, sometimes in 2021, it will automatically expire by the end of this year. Again, HFO, those are the typical replacement for HFCs. And at BASF, we have WALLTITE CM01, which is our HFO-based closed cell medium density spray foam. It's been available for about 3 years now, so it's not a new product that we're just testing now. We've used it successfully in the past. It's been 3 years. So we are comfortable moving forward with this product. In terms of the differences between the two different foams, if we take the previous generation of closed cell spray foams with HFC and compare them to WALLTITE CM01, which utilizes HFO, the density is pretty much the same. It's in the same range. We have a minimum density of 1.85 pounds per cubic foot for HFO CM01. The R value is slightly lower, and there's two main reasons for that. First of all, the blowing agent itself is causing that slight reduction. And the other reason is the standards to determine the R value has been updated in the new National Building Code. And that change is causing a slight reduction in the R value as well. So if you took the same product, tested to both standards, the old version and the new version, you're gonna have different results. But the big thing here is really the GWP, or the environmental impact of the foam. So we went down from a GWP for the blowing agent of slightly over 1,000 to less than 1. That's a significant improvement. And if we look at the finished product, we went from 20 to 4, and that's for a surface area of 1 meter square, thick enough to give you an RSI of 1 or R value of 5.68. As for the other properties, nothing really changed. Either way, it's an air barrier material. When sprayed to a certain thickness, it will act as your vapor barrier. Water absorption is really low, and the application is the same. You can use it on the interior as the insulation between the studs, directly on your foundation wall from the inside. It can be used as the continuous insulation from the exterior, and it will add structural strength to your overall assembly. So for those who are not really familiar with an EPD or an environmental product declaration, that's basically a document or a report that tells you the whole story of the environmental impact of a product. And it's especially useful if you want to start comparing different products. So it is independently verified based on ISO standards. It's not a document that manufacturers would create. As a spray foam industry, we have one with ASTM. So if you just Google ASTM EPD-085, you'll get the first result that pops out is going to be the EPD for spray foams with HFO. It is based on the full life cycle assessment of the product. So again, it takes into account everything. And then you end up getting the actual GWP of the product, the carbon footprint, the embodied carbon of that product. And the functional unit used is, again, it's 1 meter square, and a thickness that would give you an R value of 5.68. And this is what really allows you to start comparing between different insulations. So I mentioned earlier, it does take into account the full life cycle of a product. So we're talking from the very beginning, extraction of raw materials, manufacturing those materials and making use of them, the actual installation on site, and transportation, by the way, is included in every single phase here, to the use of the product throughout its life, and all the way to the disposal of the product at the end of its service life. So it's really a cradle to grave kind of approach, which takes into account everything. If we start comparing different insulation products, this is a chart that shows you the GWP of different products that was taken directly from the respective EPDs. So if, again, you compare WALLTITE V3, which was HFC based, with WALLTITE CM01, you see the difference, how we went from a GWP of 20 all the way to 4. In fact, if you look at the EPD, that GWP of 4 for WALLTITE CM01, sorry, can further be reduced because one of the main reasons why the GWP is at about 4 is the use of diesel generators on site. So if contractors would find a way to switch to electrical power, that would further reduce the overall GWP of the product. You can also see that now WALLTITE CM01 is actually less than semi-rigid mineral wool. It's fairly close to other types of batt insulation. Just one note about EPDs and GWP. Although this is a great tool to start comparing different products, you have to keep in mind that certain products would fulfill more than one function. So if you take, for example, spray foam WALLTITE CM01, it is your air barrier and it is your vapor barrier at the same time. So you're not going to need to add the GWP of an additional air barrier or vapor barrier to the overall GWP of your assembly. Whereas if you take a typical fibrous insulation, you're going to have to take into account that you're adding an air barrier or sometimes a separate vapor barrier as well. So just some thoughts to keep in mind here. One of the main advantages of having that EPD is if you're looking to have your project LEED certified, you get points for having that EPD. You also get points under material ingredients. So we work with HPD builders and we get a health product declaration, which is basically a report or a document that ensures accurate and reliable. Sorry about that. It ensures accurate and reliable reporting of the ingredients we have in our product. So it's pretty much similar to a safety data sheet. And finally, you also get points under low emitting materials. So WALLTITE CM01 does comply with the California Department of Public Health standard method, which basically means that VOC emissions are checked and verified and under the requirements. So we also have the Green Guard certification, which basically certifies that we meet strict chemical emissions for indoor use. We also have the Green Guard Gold certificate, which is even more stringent criteria than the Green Guard. And this is to take into account sensitive individuals. So it applies mostly for schools and healthcare facilities. We also have the Ecologos certification, which certifies that the product has a reduced environmental impact. So moving on to a few changes happening in the National Building Code and the standards. So the current version or the latest version of the National Building Code is the 2015 version. They're actually working now on the 2020 version, but it's not published yet. 2015 replaced the 2010. It includes more recent standards. So if you look at Division B, Part 1, you have a long table with all documents and standards referenced in the National Building Code. One of the standards that would apply to spray foam is CANU LC S705.1. This is the material standard for closed cell medium density spray foam. The 2010 Building Code referenced the 2001 version of that standard, and the new Building Code is now referencing the 2015 version of that standard. So the difference between these two standards, or I should say the main difference in those standards, is that CANU LC S770, which is the test method for determining the R value, has been updated to S770 2009. And by the way, LTTR here means long-term thermal resistance. So it's not the initial R value. And this method the new method is slightly more complex, or I shouldn't say slightly, it's a bit more complex than the older version. And that's why you get a slightly lower R value at the end. We'll get into that on the next slide. Another change is that the initial thermal resistance is no longer required to be declared under the new standard. And that's just because at this point, this is a meaningless value because you can't really use that value as your design R value. The only R value you can use in your design and calculations is the LTTR. The initial thermal resistance doesn't mean much. And it was just causing confusion on field with a lot of contractors claiming a really high R value per inch without really mentioning this is the initial R value, which cannot really be used anyways. Another big change is there is now a limit on how much the foam itself can shrink under certain temperatures and relative humidity. So that's a limit of 2% now. So more stringent dimensional stability requirements. And a requirement was added to ensure that there's no fungi growth on the spray foam sample. So for the LTTR, without going into details here, it's basically the way we prepare the samples and test them has changed, and the way we do the calculation, determine the aging factor and all of that. So all of those changes are meant to give a more accurate and representative R value of what you're going to have in real life. And I'll turn it over to Chris.
Okay. Yeah, so we talked a little bit, or those of you that are familiar with spray foam, you all know that it's a site manufactured product. And with that being a site manufactured product, there's a lot of quality control checks that need to be done on site by the spray foam installer. And there's actually a lot of stuff that's done behind the scenes with regards to the site quality assurance program to make sure that our installers are qualified, so that you as engineers and specifiers and builders know that you're getting a quality installation that meets the requirements of the building code. So there's for BASF, we use a company called Caliber Quality Solutions as our third-party quality assurance program provider. They're certified to ISO 17024 for certifying spray foam installers. And they follow a new standard called the Annual CS718 Site Quality Assurance Program Standard. So this is basically a guideline for all the manufacturers and quality assurance program providers to set the minimum bar that you guys want for the spray foam being installed on your project. So, and they're all, this is all making sure that the installers are applying the foam as to the Annual C705.2 application standard. And that's a standard that's referenced in the actual National Building Code as well too. So this is where all the code compliance comes in. So part of the stuff for you guys to kind of make sure that you're getting a quality installation is making sure you're using a registered contractor. You can ask them for their registration card or proof of good standing by the certification organization when they're quoting on the work. And also the actual installer that's doing the work, the general contractors on site or the site quality person, they should be asking the installers for their certification card just to show their certification card to basically verify that these guys are certified, they're up to date, and they've kind of shown that minimum level that they're qualified to install spray foam. And with regards to a paperwork review as well, there's each installer for every job. They're supposed to, or they need to fill out a daily work record. So again, as a specifier and an architect or a builder, is ask for a copy of the daily work record at the end of the day or at the end of the week, depending on the size of the project. They should have multiple filled out. They need to fill one out at the beginning of the day, every time they change jobs, and every lot number. And it's a good quality control check. And essentially the minimal paperwork you guys want to be looking at on this, again, from your quality control standards, is to make sure that it's referencing a CCMC listing. So here we have the 141001L for a WALLTITE CM01. And on that CCMC listing, it says what the minimum site density is in order for the product to meet the building code. So that means, as you can see, the little graphs pointing on the daily work record is the installers check their density, they check their adhesion every day. So their minimum site density needs to be higher than their overall installed, sorry, the minimum site density that they install on site needs to be higher than what's on our CCMC listing. So in our example, if we have a 1.85 pounds per cubic foot site density on our CCMC listing, we want to make sure that the stuff that's installed on site is higher than that. And that indicates that you're getting the quality installation and that your products meet the National Building Code. So we'll see if Michael's ready to come back in here. And we'll turn it over to him. Still on mute there, Michael.
There, okay.
All right.
Thank you very much, Chris and Abraham. So reasons why you would use spray foam versus other insulations. We just talked about the low global warming potential of the new versions of the foam, which are pretty impressive, being less than mineral fiber insulation. The higher R value per inch, the fact that it is an air barrier system and a vapor barrier at least the 50 millimeters thickness, and of course the prevention of mold and fungi. In terms of applications, we see a lot of specifications for spray foam and cavity wall, where it's specified as continuous insulation. And in most cases, I'd say 95% of the cases at least, it's specified just with transition membrane. So we've eliminated the full coverage membrane. We also see it in stud walls between framing, whether it's a stud wall or between joists and ceilings. So it can be applied between steel or wood studs. It can also be applied overhead on soffits, even if there's no framing. So poured in place concrete, overhead slabs, we can apply WALLTITE directly to those. It will adhere and it doesn't require any mechanical fixation. And in below grade walls, it's used as well, and we'll talk about that, and under slab. And then HP Plus is a system developed by BASF, which we'll discuss briefly as well. So in a typical attic situation, we see the video here where it's being applied on the top side of the drywall. And typically it's applied at approximately 2 inches thick. And then the rest of the insulation value is from mineral fiber or cellulose that's blown in on top. Excuse me. This becomes quite cost effective, and you're basically getting all the good features of spray foam by applying the 2-inch layer. So it's going to be a vapor barrier, it's going to stop air movement, and it's also going to stiffen up that application, the joists and such. We also see it in many unvented roofs. For well over 30 years, we've been using it in unvented cathedral ceilings where there's no need for venting. It is a closed cell product, so water vapor will not penetrate through it readily, whether it be through air leakage or through vapor diffusion. So we don't need to create a vented space because there's really nothing to vent. So that's a very effective application. As we mentioned, overhead, you can apply it. The picture there on the left shows a parking garage ceiling. So it can be applied directly to the concrete, and then it would need to be protected with drywall or a spray applied thermal barrier. And there's a number of thermal barriers you can use from AD, Grace, and other companies as well. And there's even some coating products that we can connect you with. Below grade is becoming a much bigger use for spray foam as well, for WALLTITE. Here we see it on the exterior of a foundation wall, and it is also under the slab on grade. We'll discuss that in a future slide. But you see it here on the outside of the foundation wall, where it's providing insulation, continuous insulation, and it replaces the damp proofing as well. If you need a waterproof membrane because of the water table situation, then you would apply that first, apply the WALLTITE over it, and then backfill. So it can be used with waterproof membranes as well if you need that type of thing. If you don't want to apply it full height on the outside, because when you do that, when you do apply it full height, as we show on the left, you need to protect that little bit of the insulation that's above grade. In order to avoid that, you can apply some on the inside, some on the outside, as long as you overlap 4 times the wall thickness as per the NEBC. So there it is there, you can see the sketch, how it would look. And there it is in the field. This is on a school in Northern Ontario. And you can see some holes have been cut through the spray foam because in this particular job, the applicator wanted to start applying the foam before the concrete was 28 days old. And they wanted to confirm that the adhesion was adequate based on the curing time for the concrete, which was about 10 days, 10 to 14 days. Excuse me. As you can see, the testing was done and they were allowed to proceed because the adhesion was definitely well over the minimum. The other application we see is WALLTITE on a slab on grade, so under a slab on grade as an underslab insulation, but it also provides you an air barrier, a vapor barrier, and a radon control barrier in this application. So you see him in the video applying it directly to the prepared granular subgrade, the same subgrade they would use if they're using other insulations like extruded polystyrene with a poly membrane. So they apply the WALLTITE to that and they bring it up the wall, and they can make it continuous and carry it right up the wall to the headers as well. The compressive strength of the WALLTITE is high enough that you can walk on it, you can place concrete over it. It's actually slightly higher than other insulations that are used for this application. It's over 30 PSI. So that's what it would look like in a residential application, where it's under the slab, around the edge of the slab, and then continuous right up the wall into the header space. So it basically tanks the basement and forms a continuous layer of insulation and a barrier to soil gas, water vapor, and air as well. We continue to use the WALLTITE in cavity wall construction in combustible construction and non-combustible construction, such as hospitals and schools. We've done many of those. And you can see it here being applied. On the right-hand side, it's actually a picture of a hospital application. You don't need membrane over the entire wall. You just need membrane at transitions between dissimilar materials, between the concrete and the glass mat sheathing. And of course, you need the standard through-wall flashings and to wrap window openings, but you do not need any membrane at the brick ties or at the joints between the sheathing panels. It's not required. There's a cavity wall application there as well. If you want to reduce the thickness of your wall by applying the WALLTITE on the outside as a continuous layer, and then complement that with some that's in the stud space, that can be done as well. And we've done this for many years with good results. It's a very durable application. And the reason you do this is to reduce the thickness of the wall to free up more leasable floor space. So we see this application in retail applications mostly, where they really want that leasable floor space to max out. You can also apply it on the inside of precast concrete exterior wall panels, as well as spandrel panels of window wall, curtain wall systems. Again, depending on the brand, that's something we would need to speak to you about. And also on the inside of solid masonry walls that you would find in typical old construction in Toronto in residential and commercial buildings. So we're doing a lot of this now with the focus on retrofitting existing buildings, especially government buildings. And it's also, BASF WALLTITE is also part of the HP Plus high performance wall system. This is really a separate presentation onto itself, which we're more than happy to do for any of the participants in this call. This is a system that incorporates the WALLTITE and Neopore GPS, graphite enhanced polystyrene, and it meets all the Ontario and National Building Code requirements, provides you a high effective R value, and has a small physical footprint. So the reason why we're doing this presentation now, and we've been doing this right across the country for many of our architects and specifiers, is we really want to get the word out to you about the changes that need to be made to your specs. We would really like you to update your spec to reflect the QAP program, the 718 and caliber, also to reflect the HFO blowing agent requirement, and also to show compliance of any foam that's used on your projects to 705.1-15. The -15 is very critical to be included in your specs. And to further enforce that, or to further emphasize that, I should say, we also like the LTTR R values that are required to be tested as per the S770-09. So these are the 4 changes that really need to be incorporated into specs so that you're not caught with a spec that's not code compliant, and you get involved in negotiating with the general contractor over what's to be used and other details. So if you would like us to help you incorporate these changes, we're here to help. There's a number of resources that we have. Of course, you can always call any of the presenters here whenever you need our assistance. You can email your specs or any questions to the email address there, pmconstruction@basf.com. We do have a lot of information on our website. We are updating that constantly. The other resources we offer are Word version guide specs. So we have a Word version guide spec prepared by a professional spec writer, which we can give you to use, and you can use it in its entirety, or you can use it, cut and paste sections of it into your spec. If you'd like us to update your actual spec, we offer that service as well. By using track changes in Word or in PDF, we can add comments to your spec so you can take them into consideration. And also, in order to show compliance with SB10 or SB12, you sometimes will need us to help you figure out the effective R value. Excuse me. And we can help you with that as well. For most typical assemblies, we can do this quite quickly, provide you the effective R value of the actual assembly or assemblies, so you can do some comparing and try and figure out the optimum assembly for your project. If you are using the WALLTITE and you would like someone to go out and have a look at the application, to inspect it, to make sure things are going right, we have BASF inspectors that can go out to the job site to do that. These are people that are not non-sales people. They They know exactly how to spray foam. They know all the chemistry behind it, and they can help to make sure things are going in the right direction on the job site. And also, if you need a further inspection, we can coordinate a third-party inspection using Caliber quality assurance providers. Oh, pardon me. Sorry, Abraham or Chris, would you like to add anything?
I think that's all for us to add to that. At this point, I guess, we've wanted to make sure we left time for questions. There's a big group of people on there. So I'll turn over to Natya and to the group, and feel free to start asking questions.
Thank you, Chris, Michael, and Abraham. Now we have some time for questions. If you have any questions, please post them in the Q&A forum, and I'll ask one of our speakers to address them. We already have some questions here, Chris. The first question is, did you say XPS is going to be eliminated as well?
So the regulations from Environment and Climate Change Canada are specific to the molecule, not necessarily specific to a product line. So with regards to any kind of foam plastic insulation, if they're using HFCs currently, such as spray foams and XPS insulations, by the end of 2020, they can no longer be manufactured in Canada with HFC blowing agents, and you cannot import them into Canada if they contain an HFC blowing agent. So there's going to be a few changes going on there, and it's not just specific to spray foam, it's affecting a lot of things, including automotive and the refrigeration businesses as well.
Thank you, Chris. The next question, what is the long-term thermal resistance of the R value of WALLTITE?
Ibrahim, you want to answer that one?
Sorry, could you repeat the question, please?
So what's the long-term thermal resistance or the R value of WALLTITE?
Oh, so basically it's an R value that gives you what the actual R value over the long term would be. The initial R value is not really representative when you're using gas blowing agent. Usually the initial R value will slightly be lower throughout time, usually the first few years. So the LTTR test method takes into account the actual R value at 5 years after spraying the product.
Okay. The next question, would it be possible to go over how to certify the minimum density?
Yeah, we went through that pretty quick. What I'll request is if you send an email to pmconstruction@basf.com, we put together a nice little flyer essentially that helps walk you through what to look for from the daily work record and the CCMC listings. And then also we'll give you a contact number so you can always talk with one of the local field reps with regards to what to look for on that project specifically. So,
thank you, Chris. The next question, how do these changes affect the WALLTITE product line?
So our WALLTITE XL is a specifically designed and formulated spray foam for high lift applications. Typical spray foam applications can only go up to 2 inches per pass in one lift for the applicator. We did some specific chemistry and worked with CCMC to develop a technical guide to get a co-compliance opinion with our WALLTITE XL to spray up to 5 inches per pass, just as kind of a background to everybody on that. And just like with our WALLTITE B3, we're in the process of switching that chemistry over to HFOs, and we anticipate we'll be ready by the end of the year as well.
Thank you, Chris. The next question. The city of Vancouver has a moratorium on sprayed foam on unvented roofs. Would you like to comment on that, or is there any update on that?
I looked a few months ago to see if there was any update. I haven't seen anything, any updated bulletins on that. So with regards to this, it's basically they're putting a design moratorium for alternative permit applications with regards to unvented roofs in general, not specific to spray foam. It's just spray foam is a very easy solution to an unvented roof. Essentially the reason why the city of Vancouver did this is they were getting inundated with requests to change building permits and applications after the fact. So essentially a builder was starting to put the house together, and they ran into a situation where they needed to they couldn't vent the roof. And so they went and did an alternative analysis application, which just slowed the city down. So they asked that if there's ever going to be a situation where there is going to be an unvented roof, that you use the Part 5 section and use an engineer and architect to design the building in order to ensure that if it does need to be done as an unvented roof assembly, that the proper precautions and design considerations are taken into effect.
Thank you. The next question, the building code requires venting the roof. Now, does this mean that the code has been updated to recognize your product that doesn't require roof venting?
Yeah, very similar to the last question with the City of Vancouver. So the National Building Code requires roofs to be vented unless it can be proven otherwise. And with spray foam roofs, because you're controlling moisture and air leakage very effectively on a dry roof deck, it's essentially very easy to show that it can perform properly in an unvented roof assembly. There are some code change proposals going in with a little bit of momentum behind it to get the unvented, to get that language changed to accept low air permeance foam plastic installations to be allowed in an unvented roof assembly. Our experience with it has been if the drawings are showing an unvented roof with spray foam on it as it goes to the local building officials for approvals, typically if it's at the design phase, they're fine with it and will sign off on it. It's only if they're expecting something different when they're on site and all of a sudden see spray foam in an unvented assembly that they start asking a bunch of questions. So if you're looking to use it, just make sure it's on the drawings and been approved by the city before the installation happens.
Thanks, Chris. The next question, what is the shelf life of the polyol?
On the resin side for the WALLTITE CM01, we have a 6-month shelf life.
Okay, thank you. The next question, what's the status of acceptable fire resistance for spray foam products?
So just like any type of foam plastic, spray foam for the National Building Code needs to have meet a requirement of less than 500 flame spread. So that's currently where we are with our products portfolio as well. We'll get into an assembly test. That's a little bit more complicated with regards to assembly approaches and 1-hour fire ratings and that type of thing, but there is work being made towards that as well too. And there's some design considerations that can be taken into account to make sure you're meeting the code requirements.
Thank you. A participant here is interested to know more about the options that are available for thermal barriers. Do you want to, give an email ID where they can reach out to you directly, or would you like to take that offline?
No, I can't give you any product names specifically. Spray applied thermal barriers are usually cementitious coatings that can be used as long as they meet the Annual CS124 requirement. If you want a little bit more information, just email us at that pmconstruction@BASF and we can get you a little bit more information on that as well too.
Thanks, Chris. Do you anticipate any increases in costs for the changes required to the due to the regulatory changes?
With any new chemistries, and we've seen this throughout the years as well with previous blowing agent changes, as raw material costs are different. So there is going to be a little bit difference in the price, but we're working hard to make sure that there's a minimal impact when it gets into the field, but be prepared for a little bit of price increases or price costs on that as well.
Okay. The next question, is there any fire resistance or flame spread rating incorporated into the WALLTITE CM0? In this regard, what is the recommended application regarding exterior installation?
So I'll keep going, Mike and Ibrahim, unless you guys want to step in. But so yeah, the spray foam it meets the less than 500 flame spread with regards to the National Building Code requirements and also the 705.1 required. So there are flame retardants in the product to make sure we read that or reach that. With regards to exterior applications, it's important to make sure that you're doing the proper design, and that's where we can get help or get involved and help you out with that to make sure that anything to do with the S101 or S134 wall assembly testing, we can just help you work on those requirements.
Okay, thank you. The next question, what is the load capacity to use foam insulation underneath slabs on grade? Can it be used for high traffic areas like storage garages?
The compressive strength for the spray foam is around 30 psi. So for those typical applications, we're talking about light commercial or residential applications where it's typically a footwork or foot traffic on there. So not a lot of loads. If you're talking about moving forklifts or any kind of heavy automotive equipment on there, then you're going to want to get a designer involved and make sure that that 30 PSI is going to meet the requirements, or you're going to need something a little bit heavier than that.
Thank you. The next question, what are the proper procedures for pull tests for spray applied insulation?
The CAN ULC 705.2 application standard requires that spray foam be cored and can support a 1 kilogram pull, which is equivalent to a 1 PSI pull test. We have air barrier system assemblies that are tested third party and certified through CCMC. Where we're looking for a 15 PSI, so that's very similar, where you take a core sample out of the foam, but then use a load gauge to pull up to about 60 PSI off of that. So, sorry, about 60 pounds off that load gauge in order to get about a 15 PSI value.
Okay, thank you. The next question, can closed cell spray foam act as an effective sound transmission barrier?
So closed cell spray foam, because it's closed cell, it's going to allow some noise to go through there. But because it adheres fully to everything that it's applied to, like in a wall situation, a stud wall situation, it helps reduce the rattling. Any kind of big, deep vibrations going through the wall, it's going to help dampen that. But some of the higher foot traffic or talking noises, it's still going to allow that to come through.
Thank you. And the next question, would you be able to advise what the smoke developed rating and fire rating are?
So fire rating less than 500, smoke development is very similar to that. So it's typically not tested, as it's not required in the National Building Code, but it's all in that the same 500 ballpark to meet the code and standard requirements.
Okay. So the next question is from a general contractor. He's more aware of the 2 pound versus half pound distinctions. Is there a difference between manufacturers on quality of foam that's other than the blowing agent used?
Yeah, so the distinction wise is, everyone's going to do stuff differently with regards to what kind of chemistry they're using, what kind of polyols they're using, and kind of what the benefit is to the spray foam contractor. From a designer standpoint, it's, you're going to want to be looking for stuff as to what kind of field support you get from the manufacturer, what kind of design support you're going to get, what kind of quality of the installers that the manufacturer is looking for to partner with to sell their products to, and just kind of the overall general backup and support that you would get from a manufacturer to ensure that your project goes off well.
Thanks, Chris. The next question, is WALLTITE recyclable?
The technology exists to recycle spray foams. The chemistry is there to do that, but it's an infrastructure and a cost and a demand and supply situation. So again, if there's a little bit, people want me to go a little bit more into that, again, just send an email to PM Construction on that, and we can get a little bit of information off on that type of question.
Thanks. The next question, can WALLTITE CM01 be used on the exterior side of a roof, either covered or uncovered?
For an exterior roof application, I wouldn't recommend that. We have a SkyTight C3 product with HFO in it that would be more appropriate for that. And the reason for that is once you get to an exterior roof application, there's more likelihood for foot traffic and higher compressive loads. And so a SkyTight C3 has a 50 PSI compressive strength and has a building code requirements with regards to fire resistance ratings when used as a roof spray foam assembly.
Thank you. What is the cost difference between spray foam and rigid insulation on a per inch value?
I'm not sure if you want to answer that one, Michael. I couldn't give you a dollar sign off the head, but the nice thing about the spray foam is that the cost also includes the installation, and it is manufactured on site. So it is worth the extra cost on paper. And Michael, I'll let you kind of expand on that.
Well, in many cases, if you do a direct comparison of just the insulation supplied and installed, they would be similar, but the spray foam can show us savings because we eliminate the need for things like a full coverage air vapor barrier in cavity wall, and we eliminate the need for a poly vapor barrier in under slab applications. So when you actually look at the thing as a system, then we typically would be a cost saver when we're being compared to extruded polystyrene and other plastic foam insulations.
Okay, thanks, Michael. The next question, can you use spray foam in a private pool house?
Yeah, there's no reason you can't. The main criteria there is if it's a pool, you have a high humidity environment. So you want to get a designer involved to see where your vapor barrier is going to be required in your air barrier assemblies, to see is the spray foam sufficient for what the interior conditions are like, or you're going to want a designated vapor barrier just based on the higher humidity and vapor drive.
Thanks, Chris. The next question, is this product passing ASTM E84?
This product is specific to Canada, and as such, we haven't even looked at testing it to E84 because it's not specific to the Canadian Building Code. That's a US tunnel that's equivalent to the S102. So I always say the S102 is a metric equivalent of E84. We do have, for any kind of industrial type of application, you know, tanks and oil fields, sometimes they're spec'd with some E84 work depending on where the projects are going. But we do have foams that meet those very specific for those types of engineer projects. But as far as anything to do with buildings in Canada, WALLTITE CM01 is the product line for that because it needs to meet the S102 flame spread requirements for the National Building Code.
Thank you. The next question, are there limitations on the thickness that the insulation can be applied, or is it a maximum overall thickness limitation?
For thickness, it's limited to 2 inches per pass, but depending on what you need, it just keeps on building. You just keep on building up as an applicator the 2-inch passes to get to whatever the design thickness is for the project.
Thank you. The next question, what's the average yield on the new product per set of foam?
So I'm assuming this is coming from one of our spray foam contractors. So we're typically seeing around 5,000 board feet. We want to make sure that our applicators are storing the product properly and they're using it as a fresh shelf life, not getting towards the end of the shelf life, to make sure that they're seeing those yields. And again, reach out to us and your sales rep with regards to those questions, and we'll be able to work with you and make sure you guys are getting the best use out of the product.
Thank you. The next question, have the installation temperature limitations been impacted by the change from HFC to HFO?
In general, we're still seeing the maximum 40 degrees Celsius, kind of typical recommendations. And also we're going down to about -15 degrees Celsius for wintertime applications. We've had this product go through for our installers out there, or spray foam contractors. We've used this product through several winters with a couple of field trials out there, and have had very good success down to that -15 temperature. Excellent adhesion, excellent performance, and essentially the installer didn't notice a difference going from the HFC over the HFO product line.
Thank you, Chris. The next question, what is the recommended thickness for the spray foam on underside of slab on grade for underground garages and basements with open to air slabs?
Essentially, you want to install it as per the local R value requirement. So typically you're looking at around an R24 in joists, and in garages, typically across Canada, it's an R31 R value requirement. So you're sitting around 4 inches and 5 inches roughly.
Thank you. Is there a lifespan for sprayed foam insulation?
It's designed to last the life of the building.
Okay. The next question, are there any regulations when it is used below grade and retaining walls?
Regulation-wise, it's allowed through the building code. We have testing reports available. Again, if there's any specific use on that, just email us at pmconstruction@basf.com. We can get you further information on that.
Thanks, Chris. Are there any long-term shrinkage issues that may reduce the air barrier's performance?
That's why it's critical to team up with a certified installer, so qualified and knows what they're doing, is following through the QAP program. That's why we're always working closely with our spray foam installers to make sure that they're doing everything properly and there's no issues with them, and they're trained and qualified for this. A lot of the cracking and shrinkage issues that you hear from the field, they do happen every now and then, but those can usually be pinpointed to either incompatible substrate or a substrate not properly fastened or improper application thicknesses.
Okay, thank you. The next question, I'm not sure if you've already answered it, but I'm just going to bring that up again here. What thickness do you recommend for underslab applications?
areas, I think for under slab or in a basement type of application are looking for about an R10, so that's about a 2-inch application of spray foam.
And then this is another question about Guelph specifically. Guelph requires a 10 mil poly vapor barrier as part of the radon mitigation measures. ICI building with no heat and slab don't need insulation. What is the minimum spray thickness to meet the radon requirement?
So there, in order to meet the radon requirements, you need a specific radon solution, alternative solution analysis by CCMC. So we're working closely with that. And again, you can send us an email to PM Construction and we can get you more information on that when we're ready to launch that.
Okay, another question about the price. They would like to know where you see the price point going for your product over the next year.
You know, I think the best thing is to work with your local applicators on that or your local sales reps. And we'll all work together to make this affordable solution. There's lots of benefits with using spray foam. Price isn't the only point to consider on that. There's lots of benefits out of the air tightness and the racking strength that the product gives. So yeah, just work with your local contractor on that question.
Thanks. Does long-term water saturation affect rate insulation value?
Theoretically, yes. And this is where the proper design comes in, is you don't want spray foam to be horizontal in a situation where water can sit on it. Even though spray foam very slowly absorbs water, it doesn't absorb a lot of water. When it's used vertically in a cavity wall insulation outside of the building, it can act as a rain screen. The water is allowed to drain down and the foam doesn't absorb any water. In that type of situation, it's allowed to dry. We've done the ESTM E331 testing, I believe it is, for a rain screen, and it performs. If it's being installed below grade, you want to make sure that there's correct drainage to meet the local code requirements. And if you're meeting the local code requirements, it's not going to be an issue. But usually when it becomes an issue with regards to moisture penetrating spray foam, it's when it's used as a roofing foam. And that's why it's required to have a protective coating on top of the spray foam. And also that's why you're supposed to have a slight slope roof. I think it's a 1/2 and 12 run in order to make sure that there's proper drainage on a roof.
Okay. Thank you, Chris. And the next question, does your new specification cover the entire building envelope, roof, walls, foundation, and under slab?
The new guide specification?
Yes.
Fairly generic. It could be applied to not necessarily the roof, but it could be applied to all the above grade walls, the under slab, and other parts of the building, but not necessarily the roof. But again, quite often it's useful to use our guide spec, our word guide spec, but more often than not, we find architects already have a spec section for those different areas, and we can help them modify those to include spray foam in the proper way.
Okay, thank you. One more question. The moisture content in the framing materials is a major problem on the West Coast. How does BASF manage this issue with a WALLTITE application?
That's a very good question. You know, I'm always surprised when I'm out in the Vancouver or Vancouver Island areas and see how moist everything is out there in construction. The applicators, the installers, and their estimators, everybody that's involved with the spray foam contractors out there, they know to be checking for moisture content in the wood. They know that it is an issue just in general with any kind of construction out there. You have to make sure that the walls are dry before you start putting in vapor barriers and air barriers. So the spray foam contractors are essentially just checking the moisture content before they go out there to make sure it's dry, and also during application they're checking the wall cavities to make sure that everything's dry before they apply the foam in there.
Thanks, Chris. We have time for one last question, and the question is, can spray foam be left exposed within the building interior?
No, it can't. It can be left exposed during construction, but as per the national building codes, any type of foam plastic needs to be covered with a code-approved thermal barrier, such as a 1/2-inch drywall, wood paneling, etc. So,
thank you, Chris. Thank you. That's all the time we had for questions. I'd like to thank Chris, Ibrahim, and Michael for joining us today and explaining BASF's new HFO spray foam. A recording of the webinar will be available 1 week from now. We will also send a link to the recording via email to all registrants. Thanks to everyone who attended. Before you go, please take a few minutes to give us your feedback by completing our survey. It should appear in your browser after you close Zoom. Have a great afternoon and stay safe.
Thank you.
Thank you, everyone.